Good morning, everyone. Nice to be here, and thanks for all sitting in the same place so I don't have to turn around. So this is not going to be about fancy demos. At all those shows, you hear about two things. You hear about shiny technologies, and you hear about big numbers. So I'm not going to tell you that we're going to generate so many trillions of economic value because I don't know. And I'm not going to show you fancy demos because I think we're beyond the stage. What I specialize in is in the hard slug of making it work. And most of my work is spent with executives who are financing those programs, who are financing those POCs, and we're still a bit scratching their heads. So don't take this too literally, but I pulled it, you got tons of those studies, but it seems that what it says is 74% of the executives we talk to, this is a sample of 1,086 execs across industries, do have some Industry 4.0 and digital manufacturing initiative launched, which makes complete sense, and because they understand there's indeed something out there. I don't know if it's going to be 3.7 trillions or 2.4, but there's money to be made. Everybody agrees. Now, on the other hand, only 16% of them say they're satisfied with results. Now, don't worry, it's always like this. I spent my life, in a previous life, I spent most of my time working with executives on how to not mess up an SAP deployment. And already at that time, most executives were disappointed with the result of their ERP. Now, it's a bit surprising because it's pretty black and white. If you don't have an ERP, you don't have a business. So the business case is pretty obvious. It's just being in business. Anyway, so what I find is the main reason of this dissatisfaction is that, let's face it, those execs didn't do their homework. They don't understand really what they go into. They have a superficial understanding. They've seen the 3.7 million promise. They've seen the shiny demos. But they didn't really understand what it meant for them as exec to make it a success. And that's what we're going to talk about today. How do you actually transform all that really good technology, no dismissive, this is a really serious technology, into results? Now, those execs have three main trends in mind today, pretty much across all industries. Number one, complexity. Let's face it, you see it out there. That technology is not just is not new technology, it's existing robots, and their production lines become more and more integrated. And this integration is stretching. Most of those companies have very good lean programs, and and lean is great in terms of constantly honing the performance of operations. But this complexity is stretching them, and we meet companies out there who've done great investment, who've invested in hundreds of robots, but they did not invest in the on-top technology to keep control of those robots, and as a result, whatever their lean programs are hitting a wall. Even great lean programs do not manage to get those technologies under control, and we see completely integrated lines with 50 people at the end of the line fixing quality problems because they didn't do the proper investments, they didn't change the way they were managing those lines. So number one, complexity is a huge problem. Second, goes without saying, speed and variability. It's not so much about producing steady state the same gizmos, it's about launching new gizmos, launching new releases, changing over. So this is also stretching. The lean is really good for steady state production, but it doesn't cope really well with change. So that's another. And last but not least, but this is probably the most important, and I vividly remember in my last a conversation with the CIO of a beverage company who's not Coca-Cola, the other guys. And he came to see us for a conversation around digital manufacturing, and the first sentence he said was, the people who know how to run our factories are retiring, guys like me. Those people are retiring and then not going to be replaced, and this is a huge problem. And indeed, the people who had the gut feel, who had the intuition to manage this complexity, would keep those factories humming. They are retiring, and they're not being replaced. And the next generation of engineers, they are not going to spend 15 to 20 years in the factory to get that gut feel of the factory and run it. So this is a huge problem. It's both a problem and an opportunity, because as we'll see, the experts are one of the main barriers to Industry 4.0 adoption. So a new generation coming in who's more accustomed to technology, who's more used because they have it in their pocket to use technology is actually probably good news. And as a result of this shift, what all those executives tell us is, yes, fine, I can use AR, I can use VR, but my main issue today, my OEE is 70%, and if I get to 75%, those 5% go directly to the bottom line, help me get more out of my existing assets. That's the number one question we get. Yes, and then afterwards we'll put more new technology, but right now I need to get more out of my existing assets. So we go and do analysis of what's going on. Why are the lean programs hitting a wall? Why are they hitting the wall of complexity? And why can't they go beyond this 70 to 75% OE barrier? And what we find is when you look at how this improvement cycle is, the lean improvement cycle is supported by technology, you find it's actually pretty patchy. If you look at what kind of systems do they have to collect shop floor data, you find that only maybe 30 to 40% of the shop floor data is collected by a system, and usually it's multiple systems. Then is this data put in context with other data? Because if the press is squeaking, it doesn't mean the same if the steel is coming from supplier number 1 or number 2. It always squeaks when it comes from supplier number 1. If it squeaks for supplier number 2, it means problem. And usually, that context is only in the head of the guy who retired. He's the one who knows whether it's a good squeak or a bad squeak, which is why we start retrofitting presses with microphones, by the way. Then as a result, he makes an ad hoc decision. He's going to stop the press for gut feel. And then the fix is going to ask someone to go fix it, and this fix is not going to be, again, through a system. We're not going to measure the feedback, so nobody knows after 3 times the fix has been implemented whether it's the right fix and if it should be systematized. So for us, digital manufacturing is mostly getting to what we call closed loop, where with a combination of IoT and big data, you can really support the complete loop fully with systems. And then when you go in a world where factories are 80% led by intuition and 20% with insight, to it's actually 20% intuition, which you will still need because people are going to be indispensable to improve the performance beyond keeping it alive, but where 80% is done by systems. And that's what we do for a living. And we use the kind of technologies we're going to talk about, but that's really the aim, is get to closed loop. Now, getting to closed loop is not easy. So what we do is fairly simple. You start small, and then we do lots of those roadmaps with company. On the one hand, you get the process axis. You need to get better at managing your process. So you start small with your critical assets, and then you go up. The asset, the line, the factory. On the other hand, you need to get better and better at managing technology. And here, it's mostly analytics, machine learning, and things like that. So first, you do good old dashboards, what we call descriptive. It's what's happening. Then you use predictive technologies, predictive maintenance. Then you use prescriptive, where the system will tell you not only what's going to happen, but how to fix it. And you have to take the journey along those 2 lines. The vertical line is leveraging the lean dynamic. The other one is about bringing more technology in there. And then you start simple, you start with asset performance management. Asset performance management now is a well-mastered, you find all the way from small startups to large companies, very well-packaged solution to put assets under control. There are people who have libraries of assets of predefined. Time to result is usually a few months. And then again, you get 1% more throughput out of that press, boom, direct to the bottom line. Then you go a little bit further and you deal not just with this physical big asset in the middle, but you deal with the entire line, and I'll show you a solution to do that. And then again, you gain in quality, you gain in more products, again to the bottom line. And then you go like this. But the most important, and eventually you'll get to, as you know, the end game of Industry 4.0 is what we call lights out or autonomous operations, which is, as I said, the full circle, is actually covered by a machine. Now, to get there, there's a third axis which is often completely misunderstood by companies, which is management. As a result, remember, you need to manage this notion of management, which is 80% gut feel and 20% insight. And this transition from management by intuition to management by data is the most important. And this is a third axis, which is usually underestimated. And as a result, we still see in factories, we visit factories when you walk by this absolutely giant screen, which is up the workshop, where every single KPI is in red. And then you ask the factory manager, now wait a minute, this is red, should you be doing something about it? And he says, no, wait a minute. This should not be red because of this should not be red because of that, and actually, so again, his gut feel has overridden what's on the screen, which is fine as long as he's here, which is a problem when he will retire, and which is a problem because you don't accumulate knowledge. The knowledge is in the head of people. So management transformation and getting to management by intuition to management by data is the most important transformation, and which is the one which is usually overlooked. Now, getting there is, again, the good news is technology does help. And you have really well-designed solutions today. And I told you there's many solutions that deal with asset performance management. Now we start exploring with companies like PTC or more specialized companies, the next circle, which is how do you put a line under control? How do you not only fix problems, but systematically produce good quality? And I won't describe you this solution, just give you a snapshot of the type of results. And when you see, you divide your defects by 2.8, again, directly to the bottom line. And those type of solutions, usually time to value is 3 months. So it's out there, it's available. But again, what I like a lot in this particular solution is the way it was designed. And the way it was designed was as a conversation between the process engineer, the process guy, and the data analyst. So this solution was actually designed to trigger and accelerate the management transformation so that the process engineers works hand in hand on this application with the data analyst to go from I'm running my line by intuition to I'm managing my line by data. And this solution is indeed closing the loop because it's not only saying you will be producing the wrong things, it's actually giving direct feedback to the line manager or to the machine to keep production under control. So we are there, the right technology, but whenever you select a technology, please look at this. It's not so much what it does, because powerful technologies abound. It is really of how it is done, and is it designed to trigger the management transformation. If it's only a technology where somebody tells you, give me your data and I'll provide you great results without bringing along the process engineers, be careful, this is not going to be sustainable. So, now, the roadmap as I designed is not going to be a linear roadmap. Second, if you want to bring your people along, it's going to be about experiments. So you need to design your roadmap as a series of local experiments. As I said, APM in one factory, so choosing which factories, which topic is really, really important. And going there by experiments and agreeing that some of those experiments will fail. Now, the backdrop of this, and many companies shoot themselves in the foot, they stay in experiments mode and they don't have the right governance. So, again, second thing we do a lot with companies is have the necessary decentralization of the experiments, make sure that every factory has skin in the game, that every part of the organization will be leveraged to bring their innovation. But at the same time, you have a very, very strong governance, mostly of technology, so that this distributed innovation does not result into distributed technology investment, because this ends up being very costly and very inefficient. So when you design your programs, again, don't expect it's going to be a linear. There's going to be unknown, but you should double down on governance. And again, an experience, another company which we hosted for 2 days, we hosted the management, and I was totally surprised that top management in this company was spending lots of energy of deciding whether they would go with supplier A or supplier B on the technology, but very little energy into that, into how are they going to govern the program, how would they change their management culture. When we talked about data-led management, it was really, they said, yes, we need to do it. And then they discovered that all this tedious management of who does what, and we gave them examples. We visited a dozen factories, and we showed them examples of those experiences were happening, but actually were also creating technology investments all over the map, and they had already lost control. So governance of those programs is also extremely important. Again, technology is usually easier, and you find way more people like us, by the way, who can do technologies, than people who can help you, like us as well, govern those programs. Now, it's not that easy actually, and technology does have to play a role, but again, it's in the way you apply technology. And what we find is that those pilots usually are best done on the side, which makes sense. Why? You have this existing stack. You have your machines, you have the programmers, you have your MES, and you have your SAP or whatever on top, and this thing is churning out products, and it's working okay. And there's no way you're going to touch it. It's been certified. If you're in the food and bev, touching this stack will mean recertifying, it will mean retraining people. So obviously, like we do with PTC, what you do is you put something on the side. You put a ThingWorx on the side, and then you create what some companies call this data hub. The hub allows you to do three things. Number one, collect new data, collect this context data, which usually is badly missing, collect some more data on the shop floor, collect these 3 temperatures which you did measure, which you feel are actually impacting your quality. And you do this without going through the control system, because again, this control system is certified. In many cases, it is poorly documented, so you're just not allowed to touch it. It will also allow you to collect data from existing SCADA, MES, and then you do the kind of analytics which I showed you. So this is going okay, and we're very successful as with across industries, putting this notion of data hub, like a ThingWorx, on the side, and then do the analytics and do some fairly smart things. And initially, you don't need, for the feedback, you can do something as simple as when the analytics show you that you're going to go off range, just send an SMS to the guy on the shop floor who's going to fix it. And that works really well. We do 1 pilot, 2 pilots, 3 pilots, deliver the kind of results I showed you, and then we start this difficult transformation towards data-led management. Now, this only goes so far. And then sooner or later comes the conversation with the CIO of saying, okay, I see where you want to go, but what's next? Okay, 5 years out, will I still have those 2 separate worlds of this new analytics platform, whatever it is, and my old MES? Where should I go? So lots of very interesting conversations of how do I converge those 2 things over time. We totally agree with PTC. Rip and replace cannot be the answer. No one out there will pay you the money or will take the risk of ripping and replace an MES. And they're absolutely right. For 2 reasons. Number one, they don't have the money most of the cases, and number 2, they don't want the classical MES rollout, which is the same as an ERP in nature. I'm going to define that core system and do a massive rollout. This is way too traumatic. They want it much more flexible. So, very interesting discussions with what is the end game? What is this converge thing that will take the flexibility of this IoT platform like ThingWorx, will take the indispensable transactional engine which churns orders through the shop floor in my MES and give me something I can bet on for the next 10 years. Now, what's for sure is CIOs are very clear on how it needs, not so much what it needs to be, but what are the qualities. Number one, their number one requirement is flexibility. No way this thing can be, as a classical MES. It needs to evolve every 6 months, every 3 months. People want to be able to do agile development of those functionalities. And they want to be able to, the loop I showed you, the green loop, whenever they detect something new in the factories, they want to be able to deploy a new sensor, run the analytics, make a decision in the green loop in a matter of weeks, not in a matter of months. So flexibility is their number one requirement. The second one is scalability. Potentially, the most of the companies have line-level MES deployment. Very few have cross-factory-wide deployments. And to be able to benchmark the factories, they want to be able to have that platform scale across multiple factories. So scalability is a big requirement. I didn't mention security, but obviously this goes without saying. And then finally, last but not least, as I said, and I didn't find a really good term, they want it to be incremental. So what they want is they don't want to go and again invest, spend 5 million, 5 whatever, to deploy a core system which needs to think about everything and then we deploy the core system. They want to be able to innovate constantly, bring new functionality, and that this functionality builds something coherent, that you build a cathedral one chapel at a time, but then you don't end up with a mess of chapels that don't build a cathedral. So incremental design, which is really interesting. Now, the good news is we know how to do this. We do this every single day on the front end of the business. The platforms which we build on the front end of all your businesses, on the front end of banks, to redeploy core systems in as many apps as there are client segments, those technologies are there. They call microservices-based technology that allow you to have the best of both worlds of a tightly managed technology platform that can be deployed in a very innovative way. So what we're discussing with CIOs today is, why don't we take those same well-proven technologies that run the transactions of banks, entire banks, so well-proven technologies, and bring them to the front end? So more and more, we have discussion, and there's a term raising out there of digital factory platform, digital manufacturing platform, digital operations platform, which is this blue box, the way it's shaped, this flexible, scalable, and incremental blue box. And this platform is, for instance, ThingWorx, i.e. gives you the connectivity, takes away all the slog of managing the connectivity, managing the security, managing all the mundane things. And then on top of it, expose the app platform is mostly a data model for your industry. So that's the foundation. Again, typical ThingWorx does. Then on top of this platform, there's a first level of services or application which are deployed, which are those core applications that will be mandated throughout the factory. Because you are part of XYZ Inc., and being part of XYZ Inc. means we all calculate OE the same way, we all manage work orders the same way, we all do financial reporting the same way. So this is the first layer of platforms, and this is typically, for instance, what you're going to get on ThingWorx, where most of those platforms come with prepackaged first mandatory versions. And this usually is developed and implemented by us. But where it gets really interesting is, on top of it, allow factories, partners, the richest possible ecosystem to leverage those same microservices, innovate on top of the platform. So innovate on top of both the gray core services and then create new services. And then this is where it gets really interesting, where you can combine the best of both worlds. Tight management, the bottom platform is obviously managed by the CIO. It is tightly managed, it's a critical technology investment, so locked down. But also on the top of those microservices, let any factory, any partner innovate at a much faster pace. And then the game is, so you standardize what needs to be as services. So OE calculation services, reporting service, security services, those are locked. On top of it, let factories add, I take my OE service and my security service, and I combine this super useful app on a phone that will allow my EH&S people to do exactly what they have to do in this type of factory. And then one factory does it, the second factory adopts it, becomes popular, we manage the innovation funnel, and then when it is decided, we take that app, we strip it between the front end and the back end, we transform the back end into services, and we bring them out into the platform. again, which is an innovation cycle which we routinely do on the front end of companies, which for some reason, because manufacturing has this reputation of being more complicated, which actually it is not used. So this allows you to entertain a world where some companies start even saying about an industrial app store, where factories will have available to them on the platform both the corporate apps, which again are mandatory, but also a rich ecosystem of much more granular applets that leverage the services to be able to innovate faster. And then our role, again, the key word is governance. We help companies, which again we routinely do on the front end, set up the right governance so that this mechanism of constantly scanning the innovation, bring it back into the platform to allow new innovation on top of those services, that's the key. We're right now in the pilot phase of those things, big interest. It is not totally mature. Again, what's reassuring is we know how to do it technically. Long discussions with manufacturing executive on how this can be brought into application. And again, where do you start? You start with the assets, which is really usually very horizontal, and then you go broader when you go into more specific issues. So that's the game. If I summarize, again, the technologies, what we find is technologies are there. Technology is not the issue. The real challenge to get results and why many executives still say they are disappointed today is how do you govern the program, how do you manage the transformation, the management transformation from management by intuition to management by figures. The only way to do that is to go to closed loop and eventually to go to closed loop operations. Not that people should not be on the shop floor, that people should be used to think long-term, how am I going to build the next line that's going to perform a lot better, rather than how do I keep the present line performing. And what we find is if you don't get to closed loop, you will always have, with the best intention, the guy like me who feels he's better than the system and who's going to never fix the dashboard and is going to keep walking by the dashboard year after year, knowing that the dashboard is wrong, but that he knows better. And unless you convince and you help that manufacturing executive understand that, no, it's okay, I better not be on the shop floor, I better be thinking of how do I introduce the next product, how do I think about the next generation line, while the present line is humming, Industry 4.0 remain a dream. So that was it. Happy to discuss. I understand now you're going to get a great demo, the demo you've always looking for, but I would invite you to reflect on what I just told you, because if you want a snazzy demo to eventually turn into results, you will need to have this conversation with your manufacturing executive at some point. Thank you very much.